So we've covered light and the electromagnetic wave that is produced when you wiggle an electron. We've talked about the fact that light acts like a wave and has characteristic frequencies, the spectrum, and also the fact that light reflects. So today we're going to look at another phenomenon, and that it's called refraction. So to understand refraction, what we have to understand is that electromagnetic waves can travel through some materials. If materials have just the right electron configurations, then light passes through them, and we call these materials optically transparent. The most obvious one, of course, is glass, because light passes through glass. But there are many others: quartz, diamonds, sodium chloride, various crystals all allow light to pass. So what happens is this: an electromagnetic wiggle kind of comes along, and so here comes an electromagnetic wiggle, and there's many atoms in glass, and the first atom sort of slurps up the light. Gulp. It causes the electrons to jump to the upper level, and then they jump back down. And as they jump up and back down, they produce a wiggle that is the same frequency as the original electromagnetic wave, and that sends a light out to the next atom, which gulps it up, and then that eventually falls back down into its orbital. And so through this process, the electromagnetic wave works its way through the glass until finally it's emitted on the other side. So the frequency that it comes in at is the exact same frequency that it leaves at, but what happens is this process of going through the glass actually slows light down. It doesn't travel as fast while it's hopping from one atom to the next. So even though light can pass through some materials, it always slows down. It never speeds up. It always slows down when it passes through optically transparent materials. So we are going to measure how much it slows down by this property we call n, or this parameter that we call n. Okay, so n is going to be defined as the speed of light in a vacuum, which is its highest speed, divided by the speed of light in a material. And so that ratio is going to be n. Now we're going to call n the index of refraction, and that reason won't really make sense for about 10 more minutes, but that's what it's called. So you can think of n as the slowdown factor. So imagine you got a piece of glass and light travels at 1.5 times 10 to the 8th meters per second. That's about, well, usually it travels at 3.0 times 10 to the 8th, so it's definitely slowed down. So if we want to know what is the value of n, the index of refraction for this piece of glass, we just take the ratio of the speed of light in a vacuum, 3.0 times 10 to the 8th, and we divide it by how fast light is going in this material, and the result is 2. So it's slowed down by a factor of 2. All right? So an index refraction of 2 means that light is slowed down by a factor of 2. It's half as fast as it is in a vacuum. Now here's some indices of refraction for typical materials. In a vacuum, it's 1 because it doesn't slow down at all. In air, it's 1.00029. So to 3 significant figures, this is still just 1. So although air causes light to slow down a tiny bit, it's not enough to matter in most problems. When light travels through ice, the index of refraction is 1.3. Water is 1.33. And get to glass, and it's about 1.5. And you get to diamond, and it's 2.4, which is why it makes one of the properties that makes diamonds so special. They have a very high index of refraction. So light slows down a lot when it travels in a diamond. Now, let's think about an analogy. Imagine you've got a wagon wheel, and it is rolling along the sidewalk, and it runs into the grass. What you can kind of tell is that this wheel hits the grass first, and so it slows down before that wheel does on the upper side, and that causes the wagon wheel to change directions. All right? So because one side of the wheel slows down before the other, it changes direction when it passes from one media or one area. So on a sidewalk, it goes fast, and then on grass, it slows down. So when the speed of the wagon wheel changes, when it decreases, the direction that it's traveling changes. So this is exactly what happens with light. Here's a little animation that kind of shows what's going on. Light waves are coming in at an interface where they slow down. And so down here, the light waves are moving slower, and you can see that the direction of those waves actually change. Here they're going in this direction, and now they're going in that direction. So the direction of the light actually changes when water, these are water waves, so there's the incoming wave and there's the refracted wave. And we measure those angles from the normal. So we call this the angle of incidence. And we're going to call this angle down here the angle of refraction. Okay? And that happens for any angle except that one. If the wagon wheel were to come straight at the interface, neither side would slow down first, it would keep going straight. Okay? So refraction is the bending of light when it travels from one media to another where it changes speed. And here's some illustrations. You may have had a straw in a glass of Sprite and noticed that it looks like the straw is bent right here. The straw is not bent there. That is just the light coming to your eye is getting bent. And so it looks like the light here is coming from a different location than the light there, because here the light travels from water to glass to air, and here it just travels from glass to air. So that's an example of the bending of light. If we were in class, we would pass around this big old cube, which is just a big lucite cube, and you can stick a marker behind it, and the marker is actually right here, but the light from the marker is getting bent, so it looks like the marker is over here, because that's where the light's coming from. So when it gets bent, it looks like it's coming from a different location. So refraction is the bending of light when it travels from one medium to another. All right, so we're actually going to play with a simulator and do a lab at this point to study refraction. So after this intro, go ahead and go back to your Canvas page and find the next link in the lessons, and that will introduce you to the lab and then get you started on the lab.